Section 11.3 Simplifying Algebraic Expressions. This section talks about adding and subtracting terms. But before we talk about terms, I want to make sure that we also talk about factors just for a moment. Factors are numbers or variables that are multiplied together. So, for instance, if you have 5a, 5 and a are both factors in this expression. Once again, this is multiplication. I could put a dot there if I wanted to, but there's understood multiplication there. The 5 in this particular case is also given another name. It's also known as the coefficient. If I could spell coefficient correctly, there we go. Coefficient, and the a is known as the variable. But factors are numbers and variables that are multiplied together. Terms, on the other hand, are numbers or variables that are separated by addition or subtraction signs. For instance, if you have 5m plus 3n, 5n, m is a term, 3n is a term. Now, in this term, 5m, once again, I do have a coefficient. I also have a variable. And the same with term 3 and n. 3 is the coefficient and n is the variable. If you are given 2b to the fourth, now it's not separated by an addition or subtraction sign, but there is one term here. It stands alone. It's by itself. There's one term in that expression, 2b to the fourth. If you are given 2x squared plus 3x subtract 6, this particular expression has three different terms. 2x squared is a term, 3x is a term, and 6 is a term. In this particular case, 6 is also given another name. It's known as the constant term because there is no variable that is associated with it. When adding and subtracting terms, the terms have to be like terms. Terms are called like terms if they have exactly the same variables raised to the same degree. But they can have different coefficients. So you can combine like terms. If you are given 3a plus 5a, it's kind of like saying 3 apples plus 5 apples. You can combine those. They have exactly the same variables, a and a, so I can just add those together and I get 8a for an answer. But if I had 3a plus 5b, I cannot combine those terms. It's like 3 apples plus 5 bananas. I cannot add those together. So it would just have to stay 3a plus 5b. Given 7b subtract 9b, they do have the same variables. They both have a b, and so I'm just going to subtract the coefficients. 7 subtract 9 would give me a negative 2, so I end up with a negative 2b. Another example of one I cannot combine is this, 5b to the second power plus 5b to the third power. They both have a b in them, but this is a b to the second power, this is a b to the third power, and I have to have the variables raised to the same degree. So I cannot combine these at all. It is just 5b squared plus 5b to the third power. The same thing if I have 3xy squared plus 3xy. Even though the x's are the same, I still cannot combine these terms because this term, this 3 is associated with an xy squared, the first 3. The second 3 is just associated with an xy. So once again, there's nothing at all that I can do with that. In this particular section then, you will be working on combining like terms by adding or subtracting the coefficients. So there will be a lot of review of fractions and decimals as well. If you are given this, x subtract 2/3 x, I can combine those because they are both terms with an x. But remember, there's an understood 1 in front of that x. So what I really have is I have 1 subtract 2/3. You can do that several different ways, but one way to do that is to rewrite that 1 as 3/3, so it's 3/3 x subtract 2/3 x, which gives a final answer of 1/3 x. Another example, if you're given something like 5x subtract 3.6x, I'm just going to go through and subtract. So I'm going to have 5 subtract 3.6. Just remember the importance. You cannot just bring down the 6. You have to put a 0 in with that in tenths place, and then go through my subtraction. So I get 1.4x for the answer for that particular problem. At times, you may need to use the distributive property in order to go through and combine terms. So the very first one I have here, 5p plus 4, and then in parentheses p plus 3 minus 8, I can rewrite that by using the distributive property. So I'm going to have 5p plus, and then I'm going to use the distributive property. I have 4p plus 12, because I have to multiply the 4 times 3, and then subtract 8. Once again, now I do have some like terms. I have 5p plus 4p, which gives me 9p. My constants, 12 subtract 8, 12 subtract 8 gives me a positive 4, so my final answer for that is 9p plus 4. In the second problem, I can do the same thing, apply the distributive property. 7 times 4 gives me 28, so it's 28w minus 21, subtract 25w. Now I can go through and I can combine my w's. I have a 28w, subtract a 25w. The operation in front of that particular term tells me what I'm doing with that. So it is 28w subtract 25w gives me 3w, and then I still have subtract 21. Here's one more example. In order to do this, the first thing I'm going to do is use the distributive property again. So I have 6 times 3x is 18x. 6 times 5 gives me 30. So I have 18x plus 30. Subtract 20x plus 7. Now I do have some common terms. I have an 18x and I have a 20x. Remember, the operation in front of that term tells me what to do with that. So I have 18x subtract 20x. That gives me a negative 2x. And then the other terms I have are constants. So I have a plus 30 plus 7. This is a plus 30 right here. It's a positive 30 because the sign in front tells me what type of number it is. So I'm going to add those together. I'm going to get a final answer of negative 2x plus 37. Once again, even though this is a fairly short section, it is a very important section. And if there's anything I can do to help you as you go through these concepts, please let me know.